Hi, my name is Bhargav Prashant Das, and today I am recording this demo video for this Unacademy FTE program. The topic for this is chemical kinetics, and I will be I will be picking up the activation energy part of chemical kinetics, and I am trying for or I am applying for JE chemistry part. Okay, so this is activation energy. Uh, Before going into activation energy, let me tell you what exactly is activation energy first. So activation energy maybe it has variety of meanings, variety of definitions, but the most simple and most efficient definition for activation energy is uh, maybe like the minimum amount of energy required for a molecule or an atom to undergo a chemical process, or you can say a chemical change to to bring about a product is called activation energy. Okay, so bring coming down to what exactly are the factors on which activation energy depends. Factors, there are basically two types of factors. One is types of reactants, and another is catalysts, or we can better say effect of catalysts. Okay, so effect of catalysts. So basically, as it is an active, this is also one type of energy. So the SI unit for this activation energy will be basically taken in joules per mole, or we can say kilojoule per mole, sometimes kilojoule per mole, or also sometimes we take it as kilocalorie per mole. This is mostly the three units that are mostly in use for activation energy systems. Now coming to the factors, there are types of reactants. So types of reactants, we will go the two types of reactants. One is ionic reactant, and one another is covalent reactant. Okay. So in ionic reactant, in basically in ionic reactants, the activation energy is a little less, like EA is is on lesser side, and for covalent reactants the activation energy will be with a higher side. Why is it? Because in already in ionic reactants there is an attractive force. So when the force of attraction is basically in play, the energy required to form a product required is too less. So definitely, by definition, activation energy required for the chemical reaction to happen in the case of activation ionic reactants, it is required less. So hence the EA or the activation energy will be less. But in case of covalent reactants, there are breaking of bonds, and we generally break bonds to form new bonds to, like basically what we say, the combustion of methane. So CH4 breaks into to form into carbon dioxide and water. So then the bond breaks and a new bond is like we need to manufacture like the oxygen molecules again go and connect with the carbon molecules. So in order to break the bonds and in order to in order to manufacture, in order to create new bonds, energy is required. So in that case, the EA goes higher, or the activation energy goes to be it is higher. Now coming down to catalysts, the second factors, there are two different things. Basically, catalyst means there are two different reactions for catalyst: positive catalyst or negative catalyst. But before going to into positive catalyst or negative catalyst, we will know first what is exactly a catalyst. A catalyst can be defined as a chemical entity which takes place or takes part in a reaction, in a chemical reaction, but it never actually like I can say in simple words, it never actually changes any component in the reactant. Rather, it only acts as somebody or some like some enhancer, or we can say it increases the chemical, it increases the it decreases the activation energy, or we can say increases the rate of reaction, so that the original reactants or the products, they reach to their destined original reactant, they will reach to the destined product in a shorter span of time, or in a lesser number of time as compared to which could have been originally, like it could have been a very time dependent manner. Like we can say like the HER reaction, or we can say the Haber process. N2 plus 3H2 give rise to 2NH3. This very reaction is a very slow reaction. But if we take place, or if it takes place under the influence of a catalyst, this reaction will move forward swiftly in a faster pace, in easier pace. So now coming down to the effect of catalyst in under activation energy, there are two types of catalyst: positive catalyst and negative catalyst. So what positive catalyst? What are positive catalysts and what are negative catalysts? Okay, positive catalysts are those. To be honest, positive catalysts are those which when used under in a reaction, they increase the rate of reaction and thereby decrease the EA. I will show it in a graph. Let's show it in a graph so that you will better understand it. How does this actually work? How does this actually work? Let's suppose this one is the reaction coordinate and this one is the energy coordinate. Originally, the activation, the energy line or a chemical reaction will move in this path. Start from here, go to reach here. Okay, but when we use a positive catalyst, this is the EA. This is definite. This point is the EA, activation energy. But when we use a positive catalyst, what exactly the positive catalyst does? It increases the rate of reaction, so definitely the EA comes down. So the EA comes down, and maybe this is the original EA, but when using a positive catalyst, the EA will be here. So we can see here, by using a catalyst that is positive in nature, like it increases rate of reaction, the path taken by a catalyst or the path taken by the reactants to reach to their destined product is bit a smaller path and a faster path. This is what exactly the positive catalyst does. But in that case, when we use a negative catalyst, this is better known as inhibitors. Inhibitors. We will these have their applications in enzyme kinetics. We will not go much into details about this, but what I am trying to say is, when you use enzyme catalyst or inhibitors, they increase the EA. Maybe this is the original EA or the activation energy for the said chemical reaction, but this very part here brings down, like it increases the activation energy, so that the rate of reaction decreases, or like what exactly it does is, when you use or when we use an inhibitor, it retards the reaction. The reaction comes to back, like starts working towards backward end. This is what exactly the catalysts have their effect over activation energy. Now there must be questions about what will be the role of temperature, pressure, reactant concentration, or concentration of reactants or any other entity or coefficient of reactants. These things have no role in activation energy. These things do not play any role in determining the activation energy. So these are the main, basically only the catalysts and the nature of the reactants. They are only at like the ionic reactants or covalent reactions or what type of catalysts are getting used. They are only responsible for determining what is the activation energy for a chemical reaction. Now coming down to what exactly is an activated complex. We will see what is an activated complex before moving on to the next part. Okay. Activated complex. Okay. Let us suppose originally a reactant is happening. We have this A and B as reactants, A plus B as reactants. This has to reach to its destined product as, let us suppose, A minus B. Okay, this is the reactant, this is the product. But what happens is, at some point of time, there will be this. This is the A plus B part, this part. There will be a time where this will be the highest energy point. Okay, highest energy point where this this is a transition complex, or you can say this is an intermediate complex. Okay, having both parts of A and B. So what will they examine when this complex or this entity is in equilibrium? It actually stays in equilibrium, but when it is in equilibrium and this entity's energy is higher than or equal to the threshold energy of the original reactants, then this entity is poised to bring down to be poised to go down like chemical transformation to give down this product or A minus B as product. Okay, so the activated complex is this is the activated complex when when a chemical reaction moves forward, and at a point where the complex form is in equilibrium at the highest energy point, having more energy or equal to threshold energy, the complex is called activated complex. This is how the things are moving for an activation energy thing. Okay, now coming down to the mathematical equation for activation energy. How exactly are we going to determine what activation energy is, and how exactly are we going to okay, so activation energy is, it is an Arrhenius equation. Ln K, or you can say K is equal to A into e to the power minus EA by RT, where ln K, if you take ln both sides, ln A minus EA by RT. So when we give it to like convert it into log, we will get it as log K equal to log A minus EA by 2.303 RT. Here K is the rate constant, and A is the Arrhenius equation or Arrhenius constant, EA is the activation energy, and R is the universal gas constant, T is temperature. These have their own usual meanings. R basically is taken as 8.314 joule Kelvin inverse mole inverse, or according to this EA value we change the R value, like it can be for calorie the value get changes or whatever it is. Similarly this so this is mostly the mathematical equation by which using this equation we have, then we have this EA value. Then there are further different things regarding rate constant equations we can compile, we can compare with this and make some different equations out of it, but this is the most important equation, the Arrhenius equation, which gives the relation between the rate constant and the activation energy. So that's it for today from my end. Thank you, and have a nice day.